Hello to all of you. Welcome to today's webinar on premium quality, speed, and efficiency, introducing the MJP 300WPlus. Today, we will be giving you insights into our latest advances in multi-jet printing technology and obviously the launch of our latest printer, and just give you a couple of strategic options to achieve superior jewelry casting. And now I'm happy to present you today's speaker. We have Rob Notcher with us. Rob is the product manager for jetting technologies at 3D Systems. He's responsible for driving product strategy in our multi-jet portfolio. He has been with 3D Systems for almost a decade, serving as Director of Product Development in NJP and CJP technologies prior to his role as Product Manager. So without any further ado, stage is all yours. Rob, take it away.
Okay, thank you, Lisa. Welcome, everybody. Thanks for joining. Again, my name is Rob Nochi. I'm the product manager for jetting technologies for 3D Systems. And so in the past 3 years, I've spent the focus of my time in this role on wax printed patterns in the jewelry industry. So a lot of recent experience and familiarity with the trends in the industry. Just briefly on the agenda, I think there's probably a range of familiarity in the audience with 3D printed patterns and the MJP technology specifically. So I'll just talk briefly about how it fits in the manufacturing workflow, and then the bulk of the presentation will get into printing wax patterns with the 300WPlus, which we just launched about a month ago. So this just is a overview of the jewelry design manufacturing process. So starting with the jewelry design on the left, then getting into printing the model, the 3D printed model, and then going through iterations, validating that design and prototyping. Then on the more standard path, on the lower part of the workflow, printing a master pattern and then using that pattern to make a rubber mold, and using that mold then to do wax injection parts that feed into the casting process. And the difference with the 3D printed wax patterns is we are directly printing the patterns that go into the casting process, and so we're skipping the master pattern and mold making process. So save some time and the need to store the molds, just a more efficient process. And for this one, again, the MJP process in general is set up really well for large scale production. In the diagram on the right, this actually is showing the dimensions of the models leading up through the 300W. I'll point out specifically the long dimension of 294 millimeters. We've actually increased that dimension with the 300WPlus, and I'll talk about that more later. But that's given us a little bump in productivity, and then we've also made several speed enhancements in the printer to give us additional productivity benefits. And so with this MJP process and with the 300WPlus, we get the fast job submission through 3D Sprint, fast print speeds in the machine, hands-free batch post-processing, which is one of the big benefits of multi-jet printing with wax support. And so if you take some of these productivity improvements and assume 24/7 operation with at least 30 minutes in between builds, you easily get to a volume of 15,000 or more rings in a month using our most common XHD print mode, our faster print mode. And so big advances in efficiency and productivity. As far as what 3D Systems offers in the portfolio, so the 300WPlus, I'll spend a lot time talking about that today. In the middle is the 2500 plus with the VisiJet crystal material. So that's a resin or plastic material, and that's really targeted at the fine, lightweight jewelry designs, more fragile designs. And then on the right is the Figure 4 standalone, which is a really nice low cost entry point. Has a smaller print area, but very fast print speeds. So it has a really good fast turnaround time and intended for low volume production. And so in contrast to the multi-jet printing platforms where those are really more conducive to the high volume production capability. So like I said, I'll focus on the 300WPlus today. If there are any questions about 2500 plus or Figure 4 standalone, you can put them in the chat or contact someone within 3D Systems or one of our worldwide partners for more information. Okay, I've shown this slide in past webinars. It's really just an overview of the full solution that we offer, starting with the lower left, the 3D Sprint software, which is we use for preparing files and creating the build that then submitted to the printer. We've got our 3 different wax materials, and then of course the printer to make the patterns, and then providing the services there on the lower right. We have a worldwide network of partners which have very fast response time and local inventory of spare parts to maximize the uptime of of the printers for the customers. And then that's all wrapped around the application expertise. And again, you know, we have a lot of longtime experts within 3D System and then 3D Systems, and then our worldwide partner network has a lot of knowledge of the local jewelry markets and can help address how MJP fits the particular application in their area. 3D Sprint software, I've shown this in the past as well. This is really the high-level overview of the functionality that's available in 3D Sprint. I guess one of the things I'll point out is, you know, this you see in the image, it's referencing the MJP 2500W. So this is a very high value piece of software that we've been evolving over a long period of time and building on some of the best features and continually adding capability to the software as we go. So just real quick. So again, we use this for importing files. And then there's the auto place feature to arrange the parts for optimize the print speed. It has the repair feature. If there are any problems with any of the STL files, it can help repair those parts. The auto orientation arranges the parts, again, to optimize for print speed. And then you can go in and click on any individual part and move it and arrange it the way you wish. You can copy parts across the platform, and then again use the auto place feature to optimize for print speed. And then at the end, it gives you a build time and material consumption estimate before you start the job, so you know what to expect. So again, I'll reiterate, you know, with 3D Sprint, you get a free license of 3D Sprint when you purchase a printer, and then we do quarterly updates of 3D Sprint, and so when you have a license, you have access to those updates, and we're continually adding features all the time. And I'll get into some of the features we've added for 300WPlus specifically in this presentation. So getting more specifically into the 300WPlus, we believe we're back in position as a gold standard for jewelry wax pattern printing. We've made several significant advances in different areas of performance. It's a very competitive field out there, and print quality has been pushed. The level of print quality has been continually pushed and increased, and we've done a pretty significant advance here with a new feature we're calling Surface Enhance. I'll talk about that a little bit more later. The productivity, we've increased the speed of all of our modes. We have 3 modes in this machine. XHD and ZHD are both increased by 30% over the prior model. Our QHD we've retooled completely, and that's about double the speed of what it was before, more than double the speed. We've increased the usable print area, which I alluded to a little bit before, and I'll explain more in detail. One of the biggest improvements we've made is implementing breakaway supports, which gives us faster post-processing for the productivity side of things, but also then the next big bullet there, the lower run cost. We're using less support material with the breakaway supports, and then with having to dissolve less support wax, that means less turnover of the post-processing solvents. So savings there from a cost standpoint as well. We've increased the reliability in several different components. The main one being a longer life planarizer roller, which helps us maintain a high level of PQ for a long period of time. We also have made advances to conform to the 2027 cybersecurity standard in the EU, and then we're continuing to protect our customers' IP with local management of part data and not requiring it to be shared on the cloud. Looking at printer highlights at a glance, so these are most of the say user-facing, user interface features. I mentioned before the larger print volume. So we've extended the printable area in the long direction from 294 millimeters to 309, and again, more detail later. So we continue to have the easy access material drawer, so easy remove and replacement of bottles, 2 bottles of support, 2 bottles of build. As one bottle empties, it automatically switches over to the other, and then you can also replace bottles in the middle of print jobs, so you don't have to interrupt printing if you're getting low on material. Continuing using carrying over the 3 wax materials from our prior products, and then the industrial stack light for seeing the printer status at a glance from a distance. Continuing with the UI touchscreen, and then office-friendly, low noise, low exhaust, very easy to use, doesn't require a lot of training to use the printer. And then when this gets at more of the performance aspects, when you get under the hood, so to say. So on the reliability side, like I mentioned, the long life planarizer roller, we have it not only raises the print quality level we're able to achieve, but maintains it over a long period of time. Lower run costs with the breakaway supports, so using less support material and eliminating our verification wall. And then the productivity increases I mentioned before, so faster in XHD and ZHD versus our prior model. Significant improvement in QHD as well. More usable area on the build plate and the shorter post-processing time, all contributing to significant increases in productivity. And then the smoother print quality, as I mentioned before, is surface enhanced, and I've got several pictures to show, which show the impact of that to improve the surface finish of parts. And then the data security, again, as I mentioned before. So meeting the EU cybersecurity standard for 2027, and then local management of part data. So what's new? This chart mostly is to kind of show the evolution of this particular product line. Starting on the right in the chart with the 2500W, when we originally launched that long ago, it had just the one XHD print mode. That has continued to be the most widely used print mode. And so we've maintained that as we've evolved the models over time. So that same print mode is in stayed in the 300W and now 300WPlus as well. The ZHD mode we introduced in 2500WPlus, so that mode has also carried over, and we still have it in the 300WPlus. And then, as I mentioned before, we completely retooled the QHD print mode, and both reducing the print time quite significantly, and then also reducing the material consumption to make it more competitive, and doing all that while still maintaining a high level of print quality. This is the first look at Surface Enhance. I've got a few more things I'll mention on this, but this is a diagnostic print viewed from the top. This is in XHD mode. The left image is without Surface Enhance. We use this just to show it's a good visualization of the layer lines for the different slopes. So each one of those numbers represents an angle of slope on that particular part. So 5-degree slope all the way to 20-degree slope, and you can see how the layer lines vary with those different angles. And then when you move to applying the Surface Enhance, the layer lines are still there. They just are softened quite a bit, and so very significant improvement in this diagnostic print. And then we've got that carries over to actual customer applications. And so as we've implemented this in 3D Sprint, the Surface Enhance is on by default, but we you see in the window there on the right that it's a checkbox, so the customer has the ability to turn it off if they wish. And so just wanted to make sure that we left the flexibility in there to use it or not, depending on what the customer prefers. Mentioned also previously about the expanded build area. So again, moving from 294 to 309 millimeters in the long direction. That's equivalent to about 5% more area. And in this particular model, just a model with simulation with 1-inch tall rings. You see in the lower right, we've filled that empty space with 18 additional rings to increase the productivity for this full build. And so we've got that additional productivity, and then in addition, on last bullet there, we've reduced the material waste by 13 grams in this particular case by eliminating the weld altogether. And although 13 grams may not, it may or may not seem like a significant amount of material, but there's certainly a psychological advantage by not throwing away that block of material at the end of the job. It's nice to reduce the waste. There's definitely a psychological advantage by not having to throw away as much material. One of the most positive areas of feedback that we've been getting is really the benefit that the Brakeaway supports brings in decreasing time and waste. So you see in the images, so the lower left, this is our previous 300W model, and even the prior models before that, where we used to have a solid support, and then you see the arrow pointing to old raft. This is just a base layer that we always put down before. And so we've done two things. One is we've reduced the thickness of that raft, which has given us a 25 to 30% benefit in support material usage. And then the breakaway supports you see in the next image over, it's more of a column structure, and those, so one, you're reducing the amount of material, of support material consumed, but also those, you can brush away those supports with your finger. And so you see after brushing away, breaking away those supports and brushing them off, you're left with the image on the far right, which is just a thin layer of support at the surface of the part. and that's all that needs to be dissolved in the post-process as we go through the IPA bath. And so you see the times down at the bottom where, with the old solid supports, we were about 13 minutes. And with this breakaway support, that part on the right took about 8 minutes to dissolve that material that was remaining. And we've actually that's a conservative estimate. We've got some feedback from customers and partners that they've even seen as low as 5 or 6 minutes for getting that last bit of material off. So so there's, savings in support material, savings in post-processing time. And then the other thing, which I made a quick reference to before, the last bullet in the text there, you see that you extend the usable life of the IPA rinse bath. So less support material loads up the bath much less, and so it takes longer. You have longer time intervals between when you have to change the bath over and replenish. So lots of good benefits out of this particular feature. And this, again, it's on by default, but you can, the customer has the option to deselect if they want to go back to the solid support for any reason. Again, the hardware improvements, mostly we were going after these offered us some performance benefits for sure, but also we were trying to improve the reliability of the product as much as possible. And so I talked about the planarizer before. There's a new blade that goes with that. It's designed to be much longer life, and so enabling the higher print quality consistency over time. The Y-axis motor, the third one down there, that Y-axis motor assembly is similar. We have a longer life assembly, so it helps maintain that high level of quality over time. We also updated our EPC, which is our controller, our main controller in the printer, and upgraded the memory. And the memory has the benefit of one, giving us more capability with the surface enhance, and then also enabling customers to run larger jobs if they choose to do so. And I'll go back to the top of that slide. As we referenced, it's about a third of the 300W hardware replacements so far were from this list of components. And so if the customer, we always highly encourage the customer to stay engaged with their selling and servicing partner to make sure we do preventive maintenance over time. And then with these reliability improvements, you should get a very high level of performance over a very long period of time, several years. This slide is very much focused on the throughput, and there's a couple things that I want to point out here. One thing is we're trying to get to a metric that enabled us to compare throughput for different build sizes and also make competitive comparisons where maybe competitor machines have a different size build plate. So in the table you see for each case, so we've got all 3 print modes across the top, and then on the left column moving down, it's single lane, 2-lane, and 3-lane builds. And so and then in each one of those cells essentially is a total number of rings in this particular simulation, the build time required to print that number of rings, and then that's then calculated a number of rings per hour. And so that rings per hour gives us a nice basis for comparing different print modes and comparing to competitive products. And so let's go to the far right column, the QHD. As I said, we retooled this to significantly improve both material consumption and the print time involved. So to try to fit better into customers' workflows. So originally in the 300W, our QHD had a really high level of print quality, but took a full 3-lane build took on the order of 40 to 50 hours. So, customers had to really plan around that, maybe do prints over the weekend or just count on the printer being down for a couple of days while I was doing that job. So now that we've retooled that, we're gotten down to an 18-hour time for a full build, which is more conducive to daily workflows. And so, for example, if a customer wanted to print strictly in the high-res QHD mode in one model, they could print a single lane job in during the day shift. You see about 5.2 hours, and then at the end of that, then switch over and do the full 3-lane build overnight and have it be done during the main shift the next day. So that's one nice improvement on workflow. Then moving over to XHD in the left column, as I mentioned before, this is the most widely used print mode historically in all the models. And now that we've got the full 3-lane build down to 9.5 hours, that's fits in an extended day shift. So a little more flexibility there. And then last thing I'll mention on this is for quick builds within jobs that need to be done within the day. You have options with any of the print modes. So you see the single lane build for XHD just under 2.5 hours, up to QHD of 5 hours that I mentioned before. So any one of those modes, you could turn around a job within the day. So one of the pieces of feedback we always get, you guys are always comparing to yourself and how you did in the past. How about how you compare to other printers in the market? And, as we know, like I said before, and we all know, the competition has heated up in the last several years from print quality and throughput standpoint. So just want to take an opportunity to do some quick comparisons. So throughput, as I mentioned before, using that rings per hour metric as a way to be able to compare across, compare to competitors' printers. So what you see in the chart on the right, the 3 shorter bars, the 2 in the middle are the rings per hour for our ZHD and QHD modes currently. And then you see how that compares almost exactly to a standard build mode for one of our chief competitors. And so we're essentially getting comparable quality at comparable throughput in this case. And then again, with our most commonly used mode with XHD, if that level of quality is good enough, you actually are getting double the throughput in that mode. So still keeping the options available to our customers depending on the level of quality they choose to go with. This is a zoom in on some of the effects of surface quality with the surface enhanced features. So again, taking one of the competitor printers, same print, they've got a single mode, so all 3 images in the right column are the same image. And then we've got our 3 modes. If you go down the left column, QHD, ZHD, and XHD. So with 300WPlus, that left set of images is just as is, no surface enhance applied, just a baseline. And so you see, and so then if we focus on the bottom row, so our XHD, you can see the layer lines in that lower left image, which you would expect on a shallow contour at 1600 DPI in the Z direction. You're going to see layer lines, and you can see similar in the competitor image there. Then what to draw attention to is in the center, we've applied the surface enhance, which is done made a significant improvement in reducing the visibility of the layer lines there. And then if you continue up, so again, that center image, you're getting at twice the speed of the one on the right. And then as you move vertically in that center column, now ZHD, which is where, this is the kind of application, this shallow contour on a flatter part. That's where ZHD offers the biggest advantage. And you see even in, there were more subtle layer lines to begin with, but now they're almost completely gone. And then again, QHD, which has that's the image at the top, the layer lines were a little softer. This is higher resolution in all axes, and actually you're getting a good benefit there too. So Surface Enhance actually is a really nice feature, especially where we're getting to these really shallow upward facing contours. And also it's also effective in the other axes as well. But this example really emphasizes that upward facing contour. This is just taking that old image and extending. We got some feedback before about how competitor was using, hollow structure, which is, giving some benefit on saving material. And it's a great benefit. They save a fair bit of support material in that application. But the observation was that the supports were not easy to break away, so you still have to dissolve all that material. And so that's where our breakaway supports give us a little bit of advantage in the post-processing time. So again, the center image, after you've removed the breakaway supports, you're just left with that thin layer, so much less material to dissolve. And then the jetting wall, again, just comparison to one of the competitor printers. That in actuality, the two walls, although they're different design, different form factor, they roughly use about the same material. And then when we did the breakaway supports, that dropped the amount of material in the wall by 30%. And then, but of course, right, the best thing is if you don't print the wall at all. So, we've given the customer the option to turn that jetting wall off, and therefore then you're not wasting that whole block of material. And one thing I didn't clarify, you can probably ask, well, why did you have the jetting wall there in the first place? And so there are several reasons in this technology. Several of the print process components were somewhat dependent on having that jetting wall there. They gave us more consistency. It gave us more consistency in the print quality. And some of the advances we've made in the 300WPlus basically have eliminated the need for the jetting wall. So at least in most of the applications, the things we've tested, that jetting wall is not essential. So our recommendation is try it without the wall, and just save that material. So then getting into the materials, again, we have our three same materials that we've had before. We carry over from the previous models. The M2 cast is the original material in this particular product line. It's a harder material, has sharp details. The color of it shows the contrast really well, so you can see the details and features very easily. Then the jewel red was introduced, specifically targeted at some of these lighter weight, fragile designs. It's a softer material, so it's more conducive to handling some of these more fragile designs, and they survive the post-process sequence much more at a much higher rate. And then the Rubi was then also as a result of a request to have something that was a good compromise and balance between the benefits of the two materials. So it gives a little more stiffness, but it also gives, it's not as brittle as the M2 cast. So that's made it our recommended material for presetting of stones. This slide, mostly all I wanted to reference here, this is created for customers who may have one of our prior models, so 2500W or the 300W as well, showing common print modes. So XHD is just showing the progression of our productivity improvements as you go from one model to the next. So starting with the 3-lane build, that lower right cell on a 2500W for this particular simulation would have taken 16 hours to complete. When we go to 300W, that gets down to less than 13.5 hours. And then when you go with this new 300WPlus, with the improvements we've made in throughput, you're getting down closer to 10.5 hours for this particular job simulation. And then the ZHD and QHD are just shown there for reference again. So very significant if you're a current owner of 2500W and make the move to a 300W+, that's a pretty significant savings in print time, going from 16 hours down to 10.5. So getting a little bit into best practices, this, I'll explain this chart first, how this is structured. First look at the title. This is is best practices for print mode selection. So mainly I'm targeting which build mode is most suitable for a particular application. And the other piece, I'll talk about the material later. That's a lower section of the table. I'll talk about that at the end. But I'll go to the right-hand table where material usage, time, and surface quality. We're just giving those kind of bronze, silver, and gold ratings relative to one another. So the material usage, you can do the breakaway supports and turn the jetting wall off in all 3 modes. So all of them are very high level for efficient use of material. So they have all that support material savings. And then when you go to print time, as mentioned before, the XHD is much faster, 80 to 90% faster than the other 2 modes. So that gets the gold, and then the ZHD and QHD are equivalent speed to each other. They get the silver. And then surface quality, the XHD is the base level. That's the bronze. ZHD gets a silver, and what I'll point out on the ZHD is, what we've found in customer feedback is customers that have a very strict requirement for surface quality on those shallow upward facing surfaces really like the ZHD. And so I've highlighted in those red boxes the flat chains, bracelets that have, again, they're mostly flat. They have very shallow contours. That flat pendant, same thing. That's where ZHD has the biggest advantage. And then you'll see the most dots across all the applications with the QHD, of course, because it's got the highest resolution and balance across all 3 axes. So that gets the gold rating in that right-hand matrix. And then when we're talking material, this goes back to what I was talking about before, where M2 cast is a great material to use for a broad range of applications. It's the most widely used material, most commonly used. But for those, fusion designs where you've got maybe a fragile component, and then the filigree over towards the right, again, very lightweight, fine detail designs, that's maybe not going to be the best choice. The jewel red, conversely, is the best choice for those. So you see the 3 dots for jewel red for those 2 particular applications. And then the ruby, as I mentioned, is got that balance, and so you'll see that's appropriate for the broadest range of applications there. Good choice for the broadest range of applications, and again, for presetting of stones. So again, that's selecting print mode and then also selecting material. So this surface enhance, what the main thing I want to point out here, just to set reference on what the three different dots mean. So if you look down at the bottom, I'm talking about level of benefit. I'm not talking necessarily on the level of final print quality. As I spoke before, right? So it's these larger surfaces, non-flat, gradual contours, those kinds of things where you're going to see the most benefit. And so if you're looking at the applications, that's where you see in the highest concentration of high ratings is on those particular types of designs where surface enhance is going to offer the most benefit. And then XHD, of course, being the base level of quality, is where you're going to see the biggest incremental improvement with surface enhanced. There's a lot more opportunity for improvement, I guess I'll say, where ZHD and QHD maybe have already a better base level of print quality in some of these areas. And so the incremental benefit with surface enhanced will be less. And that's all I'm reflecting in this. Is so, for example, again, like if you look at the flat pendant, that's going to have it has some larger surface areas on the side. It has, it's relatively flat. That's going to see benefit from surface enhance in all modes. And if you look at the one, the Middle Eastern pendant in the center has a lot of very small details. So these aren't broad surfaces. These are very fine detailed features. And so the surface enhance will have less of an impact to the quality. If you do a before and after, it'd just be a lower impact. So this is try to really guide towards which types of designs are going to benefit the most from surface enhance. One last thing on the post-processing, this is again based on some feedback that we've gotten over time. So, our recommended methods, we have a post-processing guidelines. We generally recommend IPA bath, a temperature no higher than 37°C. For this particular design, which is relatively simple design, is on the order of 15 minutes. It probably took a little less than that to actually get rid of all the support material. But you see with the different waxes, for the most part, they've retained their color, which is also an indication that the build material hasn't been impacted by the solvent much. But it's really important to remove the parts soon after all the support wax is dissolved. Extended time in the IPA bath can impact the build wax from a mechanical property standpoint. So it can maybe increase the brittleness of the material. And then also you see this kind of white film building up on the surface of the part, and especially in the M2 cast as you get to 2 hours. And that's obviously you put it in the bath, you walked away and you kind of forgot about it and came back, and that's the way the parts look. Anyway, so that's really just to just emphasize the importance of pulling the parts out of the bath as soon after the support wax is completely dissolved as you can. So recommendations, as we said before, using the breakaway supports reduces the amount of time in the IPA, and so that actually gives less opportunity for the IPA to affect the build wax, and so but still very important to remove the parts from the IPA bath as soon as the support wax is removed. But there's other options if it's difficult to closely monitor that post-processing time. First one, from the chart on the previous page, you see, like, of those three materials, the M2 cast is affected the most. The jewel red, even after 2 hours, isn't necessarily affected all that significantly. And so if it's hard to pay attention and get the parts out as soon as possible, jewel red may be a better option. But there are also other things you can do, and something that some foundries and casting houses use sometimes is a pattern wash. And so you can do a 5-second dip of parts in the 3D Systems Easy Rinse solution, a delimining, or there's several other solvents that work, and several different pattern washes that are effective, and they can help remove that white film and restore it to the original look. And the white film, we found, some foundries and casting houses, it's a big concern for them. It can impact the final casting quality. Some it doesn't even bother them, or they already have this as part of their standard process to use a pattern wash. But it's just mostly just to share information at ways to get to a good final consistent casting quality. And so if doing a separate final dip is is inconvenient or undesirable, then another thing you can do is mix one of the above solvents in at a small concentration with the IPA, and that can help reduce the effect as well. So just some pointers there. And we will be updating our best practices documentation to include all that information. So coming back around again with the 300WPlus, we've hit a lot of the different performance vectors pretty significantly. So surface quality, productivity, the run cost, the reliability, and then also addressing our cybersecurity and IP protection of our customer part data. So hopefully this was useful to you. I guess at this point, that's the end of the presentation. I'll open up for questions.
Thank you, Rob, for a very interesting, insightful presentation on all the new features we can offer with that printer. In the meantime, Rob, I have already a first question for you. So the first one is, how does the printer compare with, and I know you talked a bit about it already, with competing Wax 3D printers in terms of precision and surface quality?
Yeah, so I think with the 300WPlus, and that we've been paying a lot of attention as we were developing the modes and making the improvements to make sure we were comparing to where competitors were, and getting help from customers and partners in doing the evaluations. How do we stand relative to the competition? And now we think, certainly with print quality, we're on par, if not better, with the Surface Enhance feature. And from a productivity standpoint, we've got the flexibility with the different print modes where, we're equivalent on speed on the high quality mode. And then if you can accept kind of that lower level of quality with XHD, that has been kind of the most broadly used mode by our customers. So you actually get a speed advantage there.
Okay, thank you. Next one is, actually I'm bundling up 3 questions now, if you don't mind, because they are basically all the same. We have questions for upgrade kits from the 300W or the 2500W. And the question really is first of all, the upgrade kit available for those printers? And if not, when will it be available?
So the upgrade kits are not available yet, as far as I know. Expectation, I think, is for and this is for current 300W customers, that it is possible to upgrade a 300W to a 300WPlus with hardware and firmware upgrade together. But those kits are not going to be available. I'm not sure the expectation now. It'll be either at the very end of this year or beginning, first quarter next year. I believe is the latest information that we got.
Mhm.
And then, sorry, I'll keep going. The 2500W, if they're 2500W or W plus, it's not possible to upgrade. They're completely different electronics and firmware operating systems. So, so it's not possible to upgrade from 2500W to 300W plus.
Okay, thank you.
Mm.
Going back to more technical questions, which is the layer thickness of the new QHD mode?
The new QHD is 14.1 microns. And so again, that the QHD is the intent there is to be more balanced from higher resolution mode in X, Y, and Z. And then if you're looking specifically at the um, well, and then the surface enhance actually can actually effectively make that look even like a higher resolution mode than that. But the 14 micron, 14.1 microns is the layer thickness.
Okay, thank you. Next one is, which is the speed of the 300W plus XHD mode compared to the XHD mode of the 2500W?
So it is about, that was in one of the earlier slides where a full build of 1-inch high in a 2500W was about 16 hours. And now we've got that down closer to about 10 and a half hours. So 300W plus is about 40%, 35-40% faster.
Okay, thank you. Does the QHD mode impact the wear and tear of the machine more compared to ZHD mode?
No, actually, it does not. Actually, there because the layer thickness is a little higher in QHD. Actually, not as many layers are printed, and so the ZHD is going to be more layers for the same height build. So that would be essentially more or less a little more wear in ZHD than the others. But that's one significant improvement we made from 300W to 300W plus for QHD is reducing the amount of passes that we make with the planarizer especially. So it's there should not be any bigger impact to printer life with that mode than the other modes.
Okay, good to know. Another upgrade question. Is the upgraded roller an upgrade from the already upgraded black roller?
Upgraded black roller. So this, yeah, it's hard for me to say a black roller. I'm not sure what that refers to. So what I can say is this is the first time this roller is offered in the wax product line. So this roller was not offered as spares in the previous products. So
Okay.
not quite, not 100% sure how to answer that question, but I don't think there is a black roller. This is a new roller design altogether.
Okay. And since you were mentioning already the wax project line, I think the next question ties really neatly into this. Will there be a 300 version of the resin projects coming soon?
So it is in our plans. It's we don't have a solid date yet. So I would say it's not going to be soon in terms of like the next 6 months. There won't be. It's uncertain exactly when that will be offered, but that is planned on our roadmap. We're just trying to figure out priorities and resources and timing and so forth.
Okay. Great. Actually, We are at the top of the hour and coming to an end of our session today. Thank you, Rob, for your time and expertise today, and thank you to our audience for the very many questions we really got, really good ones. And if you can think of any other questions, feel free to reach out, as Rob pointed out before, or other. So thank you very much for your participation and interest, and have a great rest of your day.